Hello friends, welcome back to our channel STMetaTronics. So yes, in this video we will see our password based security system code once again. So I have been getting many complaints, many comments that our code is not working properly. So we will modify the code accordingly. Now we will once go back to our code, or first we will see the simulation, if the simulation is working properly or not. First we will go to design, configure power rails. In the ground section we have voltage 0, class power, ground. In ground nets we have connected ground, VSS, VSSA. Then in the VCC we have 3.3 volts and nets connected are VDD, VCC, VDDA. In the VEE we have 3.3 volt minus 3.3 volts and no VE nets are connected. So we'll click OK. We'll double click on the controller. The part name says as STM32 F103C8. So we have uploaded our code for this controller, microcontroller, STM32 F103C8 microcontroller, which is a blue pill microcontroller. Basically we have kept the crystal frequency of 8 megahertz, that is same as the blue pill board, and we will load the hex file first. The passwords based security system, today's date is 29/9, which is matching with our system 29/9. We'll make it open, click on OK, and we'll run the code. So first string that we get is welcome, enter the password. Now we will enter the password as 12345, that is the default password that we have entered for our project. We'll check both the conditions, when we enter the correct password and when we enter the wrong password, right? So yeah, so yes, after entering the correct password we will get the welcome string, and after some time the whole system gets to reset. Okay, now we will enter the wrong password. Yeah, so after entering the wrong password we will get the re-enter password string indicating that we have entered the wrong password. Now it suggests that our simulation is working perfectly, and we will go to our code. We will look into our code. So this is our code. I'll scroll the entire code line by line for our viewers to maybe just copy it. So starting from include main.h, we have system functions, system clock config, main mx GPIO config. We have user defined functions, key press, check column, LCD initialization, LCD string, display pass variable, pass key. Sorry. So from here our main program start, int main. We have some we have declared some character where we have declared some variables. We have declared the entering string, and that is welcome. You can enter it over here. I'll modify this string as STMetaTronics. Yep, and I'll just save the code. So next time when we compile our code and load the hex file, we should see the STMetaTronics string on the first line of the LCD. Okay, so this is HAL init, then system clock config, then GPIO unit. Okay, so we are resetting the whole GPIO A pins to reset state. Then for GPIO B we are setting the 4 pins as these are the row pins that we are setting to high, right? These are the row pins and these are the column pins, right? Column pins. So row pins we are setting to high and column pins we are setting to low. Okay, then we are setting the LCD initialization, LCD string, HAL delay of 1000, then LCD. So we are initializing the LCD. we'll go in these functions one by step. Then we are displaying the LCD string, right? We are using the LCD string function for that, and we are displaying the array 0, right? We are passing it. So we will be displaying first this, then of like 1 second delay, then LCD 8080 suggests that we will go to the first line, first column of the LCD display, right? Basically go to first line, first column, right? We are using of 16 by 2 LCD, right? We are using the 16 by 2 LCD, so it will go to the first line, first column of that LCD. That means it will go to the starting line, right? Then we are displaying the enter password string, right? After welcome, like as we have seen, after welcome is displayed, after particular delay, that is the 1 second delay, we get another string over the first line, first column of the LCD, that is enter password, right? And then we wait for user to enter the password, right? LCD will go to second line, first column of the 16 by 2 LCD, right? So this will be second line, first column, okay? Second line, first column. Now in the while loop, like we have GPIO 13, we are toggling the LED pin, okay? So we can use toggle also, right? No need to set it, reset it. But for our understanding, whenever the LED pin glows and we press the key, right, at that time it will take the character input. Basically it is the polling mechanism, we are not using the interrupt mechanism, it is the polling mechanism that we are using. That's why we are just keeping some mechanism to indicate that our key has been pressed, or to indicate that at this moment we have to press this key. We can increase this delay to, let's suppose, 1,000 and once the LED starts like LED glows up, like within the 1 second we should press this key. That way the mechanism should be right. So either way we can keep this delay or we can remove this, that is not a problem. So basically I'll just show you the code first, then I'll go on to the explanation of that code, okay? Then this HAL GPIO, right, display key, okay, display key pass, and that is the same thing. And just remove it. Now I'll skip this, the system clock, then max GPIO, right? Our user variable functions that we have seen over here, right? These are the user variable functions. I'll go on explaining it one by one. So for key press, right, key press, then check column, then LCD initialization, LCD, then LCD string, and display pass key, right? These are the main functions. Then it ends, the code ends here, okay? So we will go into LCD initialization function first. So we can, as we know the 16 by 2 LCD and it is very common, so we give this set of commands. Each command has been explained over here. So whenever we pass 38 hexadecimal, it indicates that our LCD is 2 lines 5 by 7 matrix. So to display each character on the LCD uses 5 by 7 matrix, dot matrix of 5 by 7, and within the 5 by 7 dot matrix we get our character, okay? And the 8th row, basically the 8th row, that is used for the cursor, okay, blinking of the cursor. Then we keep LCD 0E, display on, cursor blinking, that means our cursor will be blinking. 06, increment the cursor, as we go on adding the character the cursor will be shifted to right. Then 01 is for clear display screen, okay? And 80x, that is force the cursor to the beginning of first line, first column of the 16:2 LCD. Okay, now we saw this LCD initialization function. It consists of several commands, right? Now inside this LCD initialization function we use the LCD, right? LCD function. So basically we are using LCD, okay, LCD function, and we are passing two parameters. First one is the value and second one is the command. Basically it indicates that whether it is a command or data, right? So if like if it is set to 0 it is a command, if it is set to 1 it is a data. Okay, so that way it is connected to RS pins. Okay, RS pin is for register select. So basically whenever this pin is set to 0, that is it is in reset state, it is a command. It is considered as a command for the LCD. Okay, and when it is set to 1 it is considered as a data. So whatever D0 to D7, whatever data is present there, it will be considered as a data when it is 1. Okay, so basically what we are doing over here, right, over here is we have 8 bit of data, right? So yeah, 1 0 1 0 1 1 0 and 0. So let's suppose that is the data. Now it should go to D7, right? D7 pin. It should go to D6 pin, right? It should go to D5 pin. It should go to D4 pin. It should go to D3 pin, right? It should go to D2 pin. It should go to D1 pin, and it should go to D0 pin. Okay, so our 8-bit data should be mapped like that, right? So what we are doing in our program is we are getting the data, right? Whatever data is here, 8-bit data. So we are ending with 0x01, right? We are ending with 0x01. That means we are ending with 0x01. All these bits will be not considered basically for now. Whatever the value over here, either 0 or 1, if ended with 1 we will get the same value, right? So that is the basic ending principle, right? We know the truth table for AND operation, we get 0 0. If 1 0 we get 0, right? 0 1 we get 0, and for 1 1 we get 1, right? So only at this condition, when both are 1 we get 1. If either of them is 0, right, if any of them 0 we get the 0. So we are using the same principle, right? Now we are ending it with 0x01, last bit LSB, and we are giving it to PA0, that is D0, right? If you see, right, I'll highlight. Yep. So PA0 is connected to D0, right? PA0 is connected to D0. So LSB, it is going to D0. Now, right, we are shifting the variable by 1. We are ending with 0x01, right? So now this bit, this whole data, right, it is shifted by 1, right? It is shifted by 1. So it will be gone and the 8-bit data will be like this. Now we are ending with 0x01. Whatever the data is, we are giving it to D1 pin, right? So whatever the data is, we are giving it to D1 pin, right? Whatever the data is, we are giving it to D1 pin, right? PA1. So if you see, we are giving GPIO port 1 PA1. Likewise, we are shifting the data ending with 0x01 and we are giving it to GPIO port pin, right? So all this 8-bit data has been mapped. Okay, all this 8-bit data has been mapped. We are giving it to 0x01. Either you can do like this, that we are shifting the variable, or we are shifting the 0x01 to left by 1 and then we are ending it. You can use any of the method. Okay, once you have like mapped all these bits, that once you have set all these pins D0 to D7 according to the data, right, we will be giving the enable pulse. Okay, so GPIO 9 port A, GPIO 9, we'll set it, give some delay and reset it. That is the pulse on the enable pin, right? So if we check enable, right, enable is connected to PA9. Okay, so a short pulse will be set on enable pin. So whatever the data present on the data lines, right, data or command, whatever data or command present on the data lines, after the enable pulse it will get latched to the latched inside the LCD. So that is, so yeah, so we understood the LCD function. Okay, we'll minimize it. Now what we are third function is LCD string function, right? So we are using the character pointer, so we are passing by reference. Okay, pass by reference, we are using pass by reference until the last character, that is the null character. Until we get the null character, right, we will increment the pointer, and whatever data present in that at the pointer, we'll send it to LCD. Okay, one means data, that we have seen here, right? One means data. Whenever this command, like this variable is 1, it means data, right? So we are sending the data, right? So likewise we are sending the LCD, we are using the LCD string function for sending the data over the LCD. Now display pass key. So whatever the pass key is there, right, we have to map it according to our character variables, and we have to display it like 1 2 3 4 5 likewise, right? So we have taken a static unsigned character pass variable, we have made it static unsigned character array of 5, right? We can increment, like if you want a long password, we can increment this array, right? Now we have to enter a correct password, we have to set the correct password, right? Here we have to set the correct password over here. I'll change this password from 54321 to, let's suppose, 33482, right? 5 digits, 33482, right? And I'll save it. Now if var key is not equals to 16, okay, so it will go over here, enter, okay, and add a 48. So why we added 48? So we know that whatever digits we get, right, if we want to print it to the LCD, we have to send the ASCII value, right? And the ASCII values are like it starts from 0x30 hexadecimal, right? That is a 48. So 0 means 48 decimals. ASCII 0 means 48 decimals. That's why we have added 48. Okay, and like in our hexadecimal we use from 0 to F, right? 0 to F, and we are using a 4x4 keypad, right? So 1 2 3 4 4x4 keypad, that's why we are taking a 16 characters. Okay, we have taken the 16 value. Now LCD, we are sending the data, whatever the key variable that we got, right, we are sending it plus 48. Okay, we are this means that we are displaying the entered key. Okay, now pass variable we are incrementing. Okay, this will basically, whatever key that we have entered, it will store it in a array. Now why we are using this? Because we want to compare the entered key with the default password. Okay, that's why. Now we have stored the first key. Okay, if pass key is equals to 5, right, what we are doing here is, yeah, so like we have entered it for a 5, right? 5 length of 5 digits is the correct password, password width for us. If we increment over here, then we have to increment the value also. Okay, so basically I'll add sign character key length, pass key length, and use equals to 5 over here, right? So okay, so if you increase the increase the value, in case you increase default password length, password pw, right? Pw length, ngth, right? So yeah, this is done. Now we are displaying it to C0. We are taking the cursor to C0. Okay, then for I is less than 0, we are incrementing the value till 5, right? Now we are comparing it over here with the default password. So compare entered password with default one. Okay, so for this we have used a for loop of 5, right? Again we will use this pass key over here and we'll do like this. Okay, now LCD string, if it is not matching, it means we will go over here and we will say that the entered password is incorrect, re-enter the password. We will set the passkey value again back to 0, so that whenever we are entering a new password, it will start writing in the array from 0th position. Okay, and we are breaking the loop basically. So we are coming out of this loop, right? If I equals to 5, right, that means the entered key, it is correctly matching with the exact length, right? If it is exactly matching with the exact length, right, this length, then we are saying that welcome, you have entered the correct password. Okay, or we are saying the correct passkey, right? Likewise, or we will say correct password, right? And then we have added a delay of 3000, right? You can always increase this delay, and you can add more operations over here. Add more OP reductions after successful password entry, right? Like opening the door, or like buzzing the alarm. Likewise, you can do anything, anything right over here. Okay, after going over here, we are again setting back to password is 0. Okay, then we are clearing the display, then we are setting the cursor for first row, first column of the LCD, and we are again saying that enter a new password. Okay, then whatever password we will be entering, we will be displaying it over the second line of first column of the 16:2 LCD. Okay, so this is display key function. I hope you understood this. That was a bit complex, but I tried to make it as simple as possible so that you should understand it. So I'll go through it again basically. So here we are comparing with the default password. Okay, we are over here totally, right? We are displaying with the entire password. Okay, if the passkey is correct, then we are displaying that correct password. Then after a 3000 delay, we are resetting the whole system, like we are resetting this whole system. Okay, so that's like it. And this if loop is set, if any wrong key is pressed, right, if any wrong key is pressed, it will come directly out of this loop basically. Okay, so yeah, that's the in short description. Now we'll go over here, right? Key check, key press and column check. Okay, so these pins are set to high. We'll go over here. Yeah. Okay, so we are setting the row pins to high. These are one, right? And the column pins, that those are connected to like ground, not ground, but yeah, those are connected to logic level 0 for default state. Okay, so for default state those are connected to logic level 0. Okay, so it is as good as switch, right? These keys are as good as switches. I'll explain it for only one column. Okay, I won't go into depth. So the switches are connected in such manners that it will connect with a row pin and a column pin. Okay, so this is a switch pin. So if this switch is pressed, okay, if this switch is pressed, this contact gets connected. Okay, so this high pin, it is connected to low. Okay, so it is as good as shorting it to ground. So it is 1 over here and it is 0 over here, right? So it is connecting as good as shorting this pin. So this logic becomes 0 over here. Okay, and we monitor if the key state becomes 0 or not. Okay, that way we can check that we can detect that which key is pressed. Okay, so go into our code. So first thing is GPIO B 0, 1, 2 and 3. Okay, 0, 1, 2 and 3. GPIO port B 0, 1, 2, 3. These are set to high. These are set to high. Okay, set all row pins to high. Then we are doing like, so if any of those GPIO pin, right, is equals to 1, right, check which column. GPIO B, PB4, PB5, PB6 and PB7, right? If any of those pins are 1 equals to 1, right, it will go check the column. Okay, if PB4 is not equals to 1, it will go for next thing. Okay, so basically, right, if we connect this you can see that PB4 become high, right? If we click this, you can see that PB8 becomes high, right? So logic 1 also gets connected over here, so that way we can check which column is which key is pressed. Okay, so if PB4 is equals to 1, right, if GPIO B PB4 is equals to 1, right, means these keys, right, 7, 4, 1 and whatever value we have provided, if it is if so if PB4 is 1, it means that one of the pins, one of the keys of this column has been pressed. Okay, if PB5 is high, one of the keys of this column has been pressed. Same goes for PB6. If PB6 is high, one of the keys of this column has been pressed. Okay, if PB7 is high, one of the keys of this column, last column, has been pressed. Okay, so according that, if PB4 is high, the one of the keys of column 4 has first column has been pressed. Okay, now we will check which key has been pressed. Okay, So in first column which keys are there? 7, 4, 1 and 10. I have assigned it as a 10. Okay, so A, B, C, D likewise I have assigned it to 10 because A hexadecimal means 10 in decimal. Okay, so we can also write it as 0xa, right? It will be more understandable. Now if like if none of the key has been pressed, right, by short circuiting or like that, so it will return, by default it will return a 16 value. Okay, now we'll go into column check, right? Now we are passing the PB4, right, GPIO 4. Now we will go over here pin variable, right? Now what we are doing is we are setting the all column pins to high, right? We are setting all rows pins to high basically. So after this what we are doing is we are resetting individual pin. That means we are resetting the individual pin to check whenever this pin goes low, and if 7 is pressed the PB4 will also go low. Okay, so we are lowering it manually, that we are resetting it manually. We are checking the state of PB4. If after resetting this pin the PB4 pin still keeps to high state, that means another key of this column has been pressed, not this one. Okay, so according to that we'll first reset, make the state of this pin to reset. We'll check if PB pin is equals to 0, then column 1 has been pressed. Okay, key for first key. If it is not, we'll set this pin, we'll reset the next pin. We'll check if the PB4 pin is equals to 0. If it is, we'll return value 2. If it is not, we'll go for checking third pin. Okay, and likewise. Then again we will set all the pins to high level. Okay, and then we will return the column value. Now according to that we have arranged the array, right? So whatever the column value is there, right, either 1 2 3 4, right, this column value, okay, column value key variable column value -1. Okay, so if first key for PB4, if first key has been entered, it will be like 0, 1 minus 1, it will be 0. That means 7 has been pressed. Okay, 7 4 1 A likewise. Okay, we'll add 3, we'll add 7 and we'll add 11. Okay, likewise, because we have arranged our this character array in such a manner. Okay, so now we will save. We'll go over here. Now we'll enter. It is working. We'll stop. Go over here. Now you can say 8:07, right? 8 p.m. 8 p.m. We'll click on open. We'll click OK. Okay. Now we have made few changes, right? So likewise, first it will be STMetaTronics will be displayed over the LCD. We'll click, yeah. So STMetaTronics has been displayed. Now we will enter the password as 12345. That is not the default password that we set in our code. So we should get re-enter password string over the LCD, right? For yeah, and 5, right? Re-enter password. Now we'll go back to code and we'll check the default password. The default password for our code right now, whatever the code that we have compiled, the default password for that code is 33482, right? So we'll enter 3, again 3, right, 4, right, 8 and 2. Okay, so we are getting the correct password string. Okay, So yes, this is a functional code right now, and I guess there are no mistakes. Slightly, I guess there might be some mistakes in my explanation in the previous videos. So I tried to correct it in this video. I'll try to share the main file and the link of the main file somewhere. Okay, in the code description. There is one more thing that I want to add here. We haven't gone through the settings, right? Like clock configuration, pinout configuration, on all these configuration settings. So we will go one by one through them. First, like as we have seen in our simulation. Oh, once over here. Yeah. So from PA0 to PA9, all these pins are output pins, right? So PA0, PA1, PA2, PA3, PA4, PA5, PA6, PA7, then PA8 and PA9. These are all GPIO output pins, right? Configured as GPIO output pins. Now PB0, 1, 2, 3. These are connected as output pins, right? PB0, PB1, PB2. These are output. PB4, PB3 is also output. From PB4 to PB7, these are all input pins. Okay, 1, 2, 3 and 4. These are all input pins. Okay, and PC13 is an input pin. So I'll just over through each of them. PA0, PA1, PA2, A3, A4, A5, A6, A7, A8 and A9. These are all GPIO output. PB0, B1, B2, B3 are GPIO output. PB4, PB5, PB6 and PB7, right? These are all GPIO input pins. Now we will go to the GPIO input pins clock configuration, right? So PA0 to PA9, right? PA0 to PA9. GPIO like output level low at initialization. GPIO mode output push pull and pull ups are connected. Okay. Now we will go for PB0. PB0 is same. GPIO mode output push pull. Pull up is connected. Internal pull up is enabled. Same for PB1, same for PB2 and same for PB3. Now for PB4 route, right, we have made so for PB4 we have configured PB4 as input mode, and pull down is connected. Okay, so PB5, PB6, PB7, same for all these pins. Okay, and internal pull up with output push pull GPIO mode, it is for PC13, right, where LED is connected, blue pill LED is connected. Okay, now we will go to RCC. So for RCC we have disabled high speed clock. Okay, we can enable it. I guess we are like we are using the internal clock, that's why we have disabled it. Analog, there is no analogs, no timers have been configured, and no UART connectivity is configured. Now we will go to clock configuration. Okay, so we are using internal clock, RC clock of 8 megahertz, right? With the PLL clock source, we have we have multiplied the internal clock frequency to 20 megahertz with help of PLL. Okay, and we have used the PLL clock source over here. So the clock that the clock that that our system is going to use is of 20 megahertz. Okay, that's I guess that's it. This is the main code, right? We will build it. We'll save it. We'll go over here. We'll load the hex file. Okay, STMetaTronics, we got this. Enter the password. We'll enter 11111. That should be the incorrect password, wrong password, and we will get the re-enter password string. So yeah, now we will enter the correct password. It is 33485. Yes, 33485, or what was the password? Can check. Yeah, 33482. So we'll go 3 3 4 8 and 2. Right, correct password. So yes, our simulation and our code both are working perfectly. So if you like my video, if you like my explanation, please give it a like and share with your friends. Thank you for watching my video. See you in the next video.